Okay, good morning, everyone. It's my great pleasure to be able to share some of my ideas and some of the ideas that we have practiced probably in the last so many years. And I'm from Tsinghua University, which you probably know. And I have had a Okay. I have had an interesting academic career, started from my old university, Tsinghua University, a long time ago. And of course, I went through University of Canterbury and University of Auckland, Monash, Xiamen University, and finally, in the last 15 years or so, set up the School of Chemical Engineering at the Suzhou University. And I did spend 3 years of real industrial experience with Fonterra, and where I was involved in the biggest dairy plant construction and optimization. So anyway, today, in the interest of time, looks like I have got 15 minutes or so, maybe less. And I'll very quickly go through the idea about LQ and life quality. In fact, in Chinese, it actually seems to be a bit more sophisticated than just life quality. Anyhow, we're getting to be old, and it's not too bad, actually. And I have defined the LQ in the sense that living condition multiplied by how you might feel about living condition. In the sense that LQ is emphasizing the feeling of the life of whatever you have got, okay? And of course that we all know IQ and EQ. In fact, IQ and EQ are probably something that our parents or even ourselves are most worrying about. And LQ instead is actually concerning of everybody. No matter whether you are disabled or you're not so smart, it does not matter. Doesn't matter. So in the sense that young, middle age or old, it really doesn't matter in the sense that we're all aiming at high LQ. Okay, if you look at from reaction point of view, I'm a chemical engineer, so today I look at it from engineering point of view, and probably hope you could easily grasp. And of course, we know that chemical reaction A plus B equal to C, which is very easy, and then you can actually express chemical reaction rate in the sense that A interact with B, then form a product of C. Okay, so very simple. And we know that our LQ, in fact, is interactive between our life, existence of our life, the material we have got, and also spiritual aspect. So you have three very important aspects. If you don't have life, of course, you don't have LQ in a sense, okay? And of course, everybody has got different sensitivity or sort of relying on the different kind of altitude of those three aspects. Okay, some people may be very sensitive to the material, some people may be very sensitive to spiritual, as you could actually understand. Okay, so if we look at it closely, you will find that, of course, our living situation is vastly dominated by the understanding of biology and, of course, the basics of the genetics and things like that. And then we can go on even further right to our environment situation affecting us in the sense. Okay, so that's all right. No, I'm sure that's easily understood. And if you look at this diagram, which I drew originally, and when we were born, we say T equals to 0. That's okay, right? That's an engineering term. And we sort of say that 100 years seems to be reasonable outcome of our life. And in fact, we expect our LQ will go along with our physics of our existence. That's okay, right? And in fact, the ending point is, at a number which no matter how many Nature Science paper we have published, how much money we have pumped into the research, we more or less actually correlating at that point. And very little progress, in fact, made. And then, of course, everybody like to have a high LQ. I mean, that period, the wider the better. And of course, our LQ really start with the appreciation of the life, Because if we don't understand what life is, and in fact, we don't actually understand LQ. So then that's fine. And we sort of go through life, and we're struggling a bit. And we ended up with the so-called elderly society, which, in fact, elderly society is actually quite positive in the sense that we all live longer. Because if we don't live longer, we don't have that issue. And so in fact, in my opinion, I'm taking it quite positively. And of course, I don't take positively about ICU, in the sense that, our ICU is designed poorly. In fact, I don't know whether it's actually designed at all. And so I'm just saying, no matter what you worry about the elderly society, but ICU has to be changed. So I have been, in fact, working with someone that hopefully we can build some interesting ICUs for the last part of life. In fact, when we have a good ending, that's a good ending. Okay. Of course, we also seem to have ignored, in certain part of the world, that there is a spiritual aspect of life. And whenever you have an accelerated path towards the end, where you actually start and where you actually understood life a lot better. And in fact, I appreciate the people who actually have a spiritual dimension, because towards the end, you could have an infinity kind of a thing. So when you look at back of my equation, that you actually realize you could have a very high IQ, or say at least a finite IQ towards the end of life. In fact, that's not bad. But however, I do ask the students every time what LQ profile you might have. Okay, so very interesting that in fact you could maybe like that. If you're really brave, and you might like that. And of course, I realized that a lot of successful people actually turned out to be like that. So in the sense that whenever you have a up and downs, in fact, you might appreciate life better. So it turns out that your LQ, in fact, the recognition is better, and you actually enjoyed life better. So when you look at it, you realize that, in fact, LQ is a dynamic phenomenon. It's not like a stationary as such. So when we look at the LQ, we notice that there are many diseases affecting us, but I maintain that biopharmaceuticals should come later after the health engineering, in the sense that food, nutrition, health is really very important right before the drugs. Okay. So when we look at the issues in your life, in fact, it doesn't matter whether old or young today, look at this particular diagram, we'll see that the diabetics diagnosed already in China and in India added up is the third largest country in the world. So you can see that it's a very large issue that we're actually facing. In fact, again, it's not too bad in the sense that today with the medical technology, that whenever you're diagnosed with diabetics, you don't drop dead like that. Don't worry, because you can live as well as probably many others. So that's fine. Except the cost will go up. The burden to the country, the burden to yourself, burden to your family may go up. All right. So when we say the elderly issues, we actually first come into is nutrition. And we may have eating difficulties. We don't have a good teeth, for example. And also the chewing ability become less. And we also have the GI tract motility, which is important, affecting us. And of course, the health maintenance in a way, that's important. Okay. So then, of course, that when we actually educate, or say we don't say educate, so in the sense that the university student today may, especially engineering, really should not just focus on science, technology, and engineering, because science and technology really drag us too far in the sense that if we don't actually understand humanity. So in the sense that the engineering schools, of course, now we do more and more doing this. In fact, I would call that LQ engineering, faculty of LQ engineering. All right. So eat and drink clearly is the most important part of our LQ. Okay, of our LQ. No problem, right? No problem in understanding that. So today, when we design food, in fact, or nutrition, in the sense that we start from molecular, this is a paradigm I proposed many years ago. It's called molecule-to-molecule approach to food engineering. And when you actually have the molecular understanding of the actual food, original food, and formulation of that, you can actually start design food. So when you design food, of course, we know the food is a biological material, so it does go bad. So you really actually need processing and innovation. Then you create the structure which is stable enough, lasts long enough, and to be able to enjoy it, and also, of course, good for business, right? Without that storage period, you wouldn't have a business as such. So anyway, once you have a microstructure, then you start talking about function and quality. Okay, without that, you can't. But whatever function and quality is, if it's food, you really have to understand it has to go through your mouth, has to go through a in vivo process. Understand? Yeah, many people, when I attend the nutrition conference, it really shocked me because it seems that the people don't actually talk about eating. They talk about nutrition per se. So it can be injections, that sort of thing. So really, food and drink is so important and really very nice to us. Of course, when you have too much, you have other technology to take care of that. So when we actually look at food engineering, I usually break it down to two parts. One is the engineering above the neck, which you understand. A lot of enterprises or manufacturers are focusing only that. And then, of course, there's an understanding important, good for our LQ, is what's going on down below. What's going on down below is very not really researched as much. But anyway, that's the thing that we have realized, very important for our engineering approach. Okay, so then I come to very quickly the so-called dynamic human nutrition. You probably never heard of dynamic human nutrition. You heard about human nutrition. So if you look at the books of human nutrition or nutrition in general, there's no such term called time. So it's very important that we realize, of course, during the day that if you eat 3 meals, 1 meal, or a meal, it's going to have a totally different impact on your life, okay? And on the left, that's a Ajahn Viradhamma, which I knew for many, many years, and a great Thai tradition monk, okay? And of course, in their tradition, they only have 1 meal a day, which is interesting. But anyway, I don't have time to explore that one. And of course, good monks. There are monks who are eating everything. But anyway, so then our life is living in the dynamics, there's no question. And if you look at the continuous blood glucose measurement, you know that where the peaks are generated and how your actually meals affecting them, okay? That's no problem. Imagine if you have n meals a day. It means many meals, small meals, but the same calorie, same total energy. In fact, you don't actually have much of a blood sugar peak, which is very interesting because that changed the view entirely from this book, Okay. So then, of course, there's many things that are dynamic right from cell level, even in the seconds and right to our lifetime. That's many, many years. And so, in fact, it is a dynamic one, no question about it. And of course, next one, I'll just quickly talk, because of the dynamic, so you can see that our digestion process in GIT process is the first dynamic affecting us, because I'm talking about food and drinks, okay? So in this case, that I will basically just start from this, that I am a chemical engineer in the sense that I was always wondering, while I was involved in a very large production technology development, I thought, when we're making food and nutritional products, but we don't actually understand very much about the GI tract issue. And of course, our medical professional friends, and they don't understand engineering, so in the sense that there is a bridge that needs to be built in between. So I have two aspects of that. One is engineers build a machine which simulates human or simulates animal, right? In fact, it can be used by the medical or nutritional professionals. Another one is that we do need to learn from each other about whatever the field. And as an engineer, I have no issue in reading nutritional or medical books because there's no equations, very little equations in there. So descriptive. Okay, so then that, of course, I have a strong interest in biology, but at the time when I was younger, I didn't know that I was interested in bionics, okay? And this is an interesting book. You realize that I bought a long time ago. I still have it. It's 42 RMB time. What is really amazing is today that if you look at the natural science, apart from the material aspect of that, and you realize a lot of this bionics development, in fact, were all actually said, all talked about in this little book. There's another little book actually written by somebody who lived to 114. In fact, a biochemist actually wrote about aging and how to maintain a good life over a very long time. And again, 74 Chinese RMB, published a long time ago. But anyway, these are good stuff. And my first approach is that I would like to turn the physiological phenomena into engineering. So basically, I was very critical through that. So if you look at the GI tract, you will realize there's something amazing. Is that our mouth is amazing. It's a crushing machine. Also, it's a mixer. And in engineering terms, and of course, it's complicated. And we have a super pipe down below, which is called esophagus. In fact, when you swallow things, you never really thought about this pipe was going to be blocked, okay? Because it does not block. If it does, then our LQ will be very poor, as you can imagine. And then you actually come through to this fantastic reactor, which is called stomach, which really does not have anything rotating as our human actually ever built, okay? But work very quietly, very powerful. And then, of course, you go through small intestine. Again, fantastic reactor, one-dimensional reactor. Of course, we have large intestine. Again, superior. Okay, so then actually we have got secretion channels delivering biochemicals to digest those materials at different stages of the GI tract, really help us seamlessly processing stuff. That's why when we actually swallow the stuff down below, we achieve 50% of LQ, yeah? No question. We also have the understanding about how the intestines, or especially colonic reactions, actually affecting how we feel. Okay, because we call that maybe the microbiome actually connecting to the brain. Okay, there are many things that I don't go into that because even the year before, I can't remember the last year what the figure was, there's $760 billion market for probiotics alone. So you can imagine that. So anyway, so you look at the duodenum. In fact, it's very complex. You can see that actually, no matter how we actually model it, I just try to show you the modeling of that. But in fact, in reality, it's so complicated. But nevertheless, we understand as soon as we engineered what's our understanding about human body, we realized that how much animal is so different from us. In fact, make you wondering, the animal tests actually have much meaning against human development or not. Of course, the FDA already approved a new endeavor that in the coming 4 years, in fact, all the animal tests for drug development will phase out. So in fact, that's very interesting that we can just build earlier, 20 years earlier than that particular concept. So then, of course, we do that. And if you take the GI tract out of body, I challenge you to think about that. Okay, so which is really amazing that our GI tract more or less like a pipe, and actually come in complicated process, but nevertheless is the only place we taking in solid and discharge solid. In fact, our body does not do that. Our remaining body is a molecular machine. Okay, which I won't say too much because of the time. But anyway, with that means that we need to look after our body carefully. Anywhere you have got a leakage of particles going to body is going to be no good. Okay. We now have built, advanced, in over the last 20 years, all these different robotics in terms of the inner robotics that simulate the GI tract. Okay. And I basically just very quickly show you some earlier models. You will see that is the stomach working, and we can see what's going on in the stomach, what's going on in the intestine. We could also develop something for infant formula, in fact, which actually got different particular angles because they lying down and drinking. So in any way, we built the world first oral processor, in fact, that can produce the same, almost similar food bolus as human. So in fact, that's really, really difficult to do. We were quite lucky, spending 8 years, but eventually we come to the 5th model and actually obtain a great result like that. Then we can look into what's going on in the teeth. How you, in fact, we actually have patented the idea you could actually design more advanced teeth for your back teeth. And because as you get old, your chewing power reduces, but if the teeth get better, and you could actually maintain a good LQ. All right, so you could also look at the colonic reactor. Now we can actually observe what's going on, actually set up the experiment in the colon, actually look at how the bacteria affecting constipations and everything else. Okay, so there's no problem. There's word first. And we also look at after you're swallowing, you may have this issue going on in the esophagus, and this is a machine, not yet commercialized, but all the others commercialized and well used by many people. And yet, you're still looking at this interesting development. This is a machine that used by our machine used by the head office of the InfoGest, which is a digestion research organization around the world. And this is there when the French TV interviewed them, and I realized that they actually showed half the time, showed our machine. And of course, for the probiotics have to survive after digestion tract, so we also have that. And we also have the infant result. Okay, I'll just very quickly go through because of time. I'm sorry. And also for the food, there's so much industries we have tapped into, and of course, we're now also going to orally deliver drug, which is, again, you can see that the usual flat reactors as commonly used everywhere in the world is not resembling human. That our system resembling human, which is very important. I just show you this interesting drug which diabetic people usually take, and you realize that with or without food, it just makes you a dramatic difference in terms of the digestion profile and also release profile, which I won't go into detail. So basically means that in the pharmaceutical area, there's a lot we can do with this system. Again, emphasis on the dynamics of the uptake, and because then they affect the dynamics in the body and what's going on. Okay, we also now combine with our large organ system with the cell level approaches. And this is the organization we belong to. And this is the future food. Interesting, a series of books, different emphasis. They haven't talked about LQ yet. Okay. So I'll just have concluding remarks. And is there a LQ product line? There's an LQ economy. Is there a dynamic human nutrition products economy, and also, of course, our bionic digestion systems are, of course, now get used everywhere in the world, and the answer is yes. Thank you very much for the attention.